back to part 2 of learning how to solve quadratic equations using the completing the square method. So in part 1, you'll remember that we learned to identify quadratics that were in perfect square trinomial form, and we learned how to factor and use the square root property in order to solve those. So we're going to continue those ideas, but we're going to be working with quadratics that are not already in perfect square trinomial form. So what we're going to have to do is a method that's called completing the square, because what we're creating is that perfect square trinomial situation. So why do we do that? We do that in order to use the square root property. So in order to use the square root property, we have to have a perfect square to begin with. So we have to put our quadratic in perfect square trinomial form. How are we going to do that? So you'll remember that we utilized when we were in standard form, we used that formula to make sure that it was a perfect square trinomial. We tested and took half of b and we squared it, and that gave us c. So today, if our c is not already in that form, we're going to put it in that form. So let's look at one problem completely through, and then we're going to walk through the process slowly. So here is a quadratic equation. Now, this quadratic equation is set equal to 0. You'll remember from yesterday that if it's a perfect square trinomial and we're using the square root property, it does not have to be equal to 0. But for our first example, it is. Now, I'm going to go through that process that we did yesterday, and we're going to take half of b and square it. Well, half of b in this problem gives me -6, and -6 squared gives me 36. You can see that this 5 is not making this a perfect square trinomial. Because of that, I'm going to move that 5 to the other side of my equation. So I'm going to rewrite my equation so that it looks like this. X squared minus 12x plus some value that completes my perfect square is equal to, now when I move the 5 over, that becomes a -5, and whatever I add to the left side, I have to add to the right side to keep my equation balanced. Now, when I went through the process of what would make a perfect square trinomial, I see that 36 makes it a perfect square. So I'm going to take that 36 and I'm going to plug it in right here and here. Like I said, whatever I do to the left side, I must do to the right side to keep my equation balanced. So what I have now is on the left-hand side, I have a perfect square trinomial. So now I'm ready to pick up with where I left off yesterday. So I would factor that, and when I factor, I can see that this number here is always going to give me my factors. This gives me my perfect square. This gives me my factors. So I'm going to have x minus 6 and x minus 6 here. If I do a quick FOIL check, that gives me x squareds. My outers and inners total -12x, and my last give me 36. So what I really have here is x minus 6 squared, and I'm going to simplify the right side, and that's going to give me 31. Now this looks exactly like where we left off yesterday. So I'll now utilize that square root property, which I will take the square root of both sides. When I do that, I'll have x minus 6 equals plus or minus the square root of 31. I'm not done yet. I still need to solve for x. So I'm going to move that 6 to the other side, and that's going to give me 6 plus the square root of 31, or 6 minus the square root of 31. So I have two choices for my answers set. And that's how you solve using completing the square. So let's start at the beginning. So our first couple questions is just going to practice completing the square. So if I'm looking at this equation here, it says, what can I make C to make a perfect square? So I'm going to start with my B term. I'm going to divide my B by 2, and I'm going to square it. That's going to give me 8, and 8 squared is 64. So for this to be a perfect square trinomial, my C would have to be 64. When I do that, this is my square term. This will factor into x plus 8 squared. Those are going to be my factors. Let's try another one of those. If you want to pause the video and try this and then check back with me when you're done, you can do that also. So I'm going to take half of b being 6, and square it. Well, half of b is 3. 3 squared is 9. So that would have to be x squared plus 6x plus 9 to give me my perfect square trinomial. If I went to factor this, this would factor into x plus 3 and x plus 3, or it factors into x plus 3 squared. So 9 completes my square. All right, so now we're ready to go ahead and solve. So I have an equation that says x squared plus 4x minus 12 equals 0. So I'm going to do that test. I'm going to take half of b, and half of b gives me 2, and 2 squared gives me 4. Well, this is definitely not 4, so I'm going to move that 12 to the other side. So I'm going to start off with a blank equation that gives me room to complete my square. So I'm going to have x squared plus 4x equals, when I move my 12 over, 12 plus a number. So I already went through the process, and I know that 4 is going to complete my square, so I'm going to place a set of 4s here. A 4 on the left, a 4 on the right to keep my equation balanced. Now I'm ready to factor. So when I factor, this is going to be my factored number. So that's going to give me x plus 2 times x plus 2, or I can simplify that to x plus 2 squared equals 12 plus 4 is 16. Now I'm ready to use my square root property, and I will square root both sides. That gives me x plus 2 equals positive or negative square root of 16, which is 4. Now I need to isolate my x, and that will give me negative 2 plus 4, which is a positive 2, and it also gives me negative 2 minus 4, which is a negative 6. So I have two solutions for my quadratic equation. I have a negative 6 and a positive 2. All right, so why don't you pause the video and try this and see how you do. Okay, welcome back. I'm going to go ahead and take half of 5 and square it. Well, half of 5 squared gives me gives me 25 fourths. And I can see that negative 6 is not 25 fourths, so I'm going to move it to the other side. So I will have x squared plus 5x plus whatever completes my square is equal to 6 plus whatever completes my square on the right. All right, so I can see that I took half of 5, which gave me 5 halves. I just left it in fraction form, and then I squared it and got 25 fourths. So I'm going to put that 25 fourths to the left and to the right side of the equation. All right, when I go to factor this, it's going to factor into x plus, remember this is the factored version, it doesn't simplify, so I'm going to leave it 5 halves squared equals. Now I'm going to find common denominators here, so I need to make this be a 4, and that's going to give me 24 fourths, because 24 divided by 4 is 6, plus 25 fourths, And that's going to nicely give me 49/4, which are both perfect squares. So that will work out very nicely. All right, now once I have my perfect square set up, I'm ready to use my square root property. And my square root property is going to give me x plus 5/2 on the left is equal to positive or negative. Now the square root of 49/4 is going to give me 7/2. So I will now isolate my x. That's going to give me negative 5/2 minus 7/2, which will simplify to be negative 12/2 or negative 6. And I will get negative 5/2 plus 7/2, which gives me 2/2 or 1. So I have two answers, one being a negative 6 and one being a positive 1. All right, let's try some more. You'll see in this problem, we have an a to contend with. So this is the first time you've ever had a value here in front of our quadratic term as far as using the square root property. So what I'm going to do is I'm going to get rid of it. I don't want an a there. That's not going to be 1. So what I'm going to do is I'm going to take both sides of my equation and divide everything by 3. Remember, what I do to the left, I have to do to the right. Now, I know I have a 0 on the right, but if I had anything else over there, I'd have to divide by 3 also. All right, now that's going to make this x squared minus 2/3 x. It's much easier if you keep everything fractional and not try to change to a decimal. Minus 1/3 is equal to 0. Okay, so how am I going to take half of b when I go to complete this square? So I'm going to do it a little different. Instead of dividing by 2, since I have fractions, I'm going to multiply by a half. Same thing, divide by 2 times 1/2. So when I divide by 2 or multiply by 1/2, my 2's cancel and I end up with 1/3, and then I have to square 1/3, which gives me 1/9. So 1/9 is the number that completes my square, but I have a 1/3. So because of that, I'm going to move that 1/3 to the right-hand side by adding it to both sides. And now I'm ready to complete my square. 1/9 makes that a perfect square, so I'm going to add it to the left and to the right. Now I'm ready to factor. When I factor on the left, remember this is going to be my factored form here. This is my perfect square, this is my factor. So that's going to give me, since this is a minus, I'm going to have x minus 1/3 and x minus 1/3. If I do a quick check, x squared, my outers and inners give me negative 2/3 and my last give me positive 1/3. I'm going to leave that x minus 1/3 squared equals. Now I need common denominators over here, so I need to make this 3 be a 9. So I will have 3/9 plus 1/9 is 4/9. And x minus 1/3 squared on the left-hand side. Now I'm ready to use the square root property. That will give me x minus 1/3 equals positive or negative the square root of 4/9, which is 2/3. I'll continue to isolate, and that will give me x equals positive 1/3 plus 2/3, which gives me 1, or positive 1/3 minus 2/3, which gives me negative 1/3. So I have two solutions here, negative 1/3 and positive 1. So you see the long process. Feel free to pause the video if I'm going a little too fast. All right, so you want to check your progress here. So go ahead and pause the video and try this one, and then you can pick it up and check your work. So the first thing I'm going to do is divide out my a. Get rid of that 2. That will give me a squared plus 11 halves x plus 15 halves is equal to 0. Once again, I've got to figure out what completes my square, so I'm going to take half of my b and square it. Well, this time half of b gives me 11 fourths, and 11 fourths squared gives me 121 sixteenths. This is what's going to complete my square. So that means I'm going to have to move my 15 halves over. That will leave me with x squared plus 11 halves x plus 121 sixteenths is equal to negative 15 halves plus 121 sixteenths. I want to make sure I do that to both sides. So this is my squared term. This is going to be my factored term. So when I factor this, it's going to factor into x plus, and this is the square root of this, 11 fourths squared equals. Now I'll need common denominator, so I'll need to multiply the top of this guy and the bottom of this guy to 8 so that I get a denominator of 16. That's going to give me negative 120 over 8 plus 100, I'm sorry, not over 8, 120 over 16 and 121 over 16. When I simplify, I will have x plus 11 fourths squared equals 1 over 16. All right, now once I get it in that system, I am ready to square root both sides. That gives me x plus 11 fourths equals positive or negative, and the square root of 1/16 is 1/4. And I'm going to go ahead and isolate my variable. X equals negative 11 fourths plus 1/4 and negative 11 fourths minus 1/4. So that's going to give me negative 5 halves. And if I subtract, I'll get a negative 12 fourths, which is negative 3. So x gives me two values, negative 3 and negative 5 halves. All right, so I have one more scenario to show you. And this scenario is, well, what happens if I end up getting a complex root? Well, let's see. So you can see I don't have an a here, so I don't have to worry about getting rid of that a. So I'm going to go ahead and try to complete the square. So I'm going to take my b and take half of it. And half of 2 squared is just simply 1. So I'm going to go ahead and move my 3 over and complete my square. So I'm going to put the 1 on both sides, and I'm ready to factor this. On the left side, I'll have x plus 1 squared. On the right side, I have negative 2. So now I'm ready to square root, and you can see that I'll have a complex solution because of the square root of negative 2. On the left, I will have x plus 1. On the right, I'm going to have plus or minus. I'm going to pull the square root of negative 1 out with an I times the square root of 2. Go ahead and isolate x, and that gives me x equals negative 1 plus I square roots of 2, or negative 1 minus I square roots of 2. And you can write it as such, negative 1 plus or minus I square roots of 2. Just recognize that this is two different solutions and they are complex. You have the real part and the imaginary part. All right, so this last one, go ahead and pause the video and try, and then pick back up and see how you did. So I'm going to go ahead and move that 5 over because I'm going to assume at this point it doesn't complete my square. So it's going to become negative 5 on the right. I'll take half of 4 and square it, and that gives me 4. So I'm going to go ahead and complete my square with my 4 and then factor with my 2. That's going to give me -1. When I square root both sides, I'm going to have x plus 2 equals positive or negative square root of -1, which is just simply I. So x plus 2 is equal to positive or negative I, and I'll go ahead and isolate. -2 plus or minus I. There are my two solutions. So that concludes this lesson on completing the square. You've seen equations where you've got complex solutions. You've seen equations where you started with an A and had to divide that out. And you've seen simple equations where all you had to do was move C and complete the square. If you have any questions, please send me an email. Have a great day.